All right. Did you enjoy your day off yesterday? So did All right, before we go on with the 3-2 notes, did you have any questions on the 3-1? Anything you want to talk about with 3-1? Anything at all? So 3-1, you need to know how to, you need to know the difference of the explanatory and the response variables. You need to know how to describe a scatter plot. You need to know how to discuss correlation. Generally okay so far? All right, then let's move on with the rest of 3-2. So this is what we did the other day. I kind of talked through this page here, just the introduction to the least squares regression model. So you guys know this as the line of best fit. We call it the least squares regression model, and I kind of showed you the little diagram with the little squares, the whole idea that Adrian Legendre came up with. All right, so these were the 3 formulas that I pointed out to you. They are on your formula page, so you'll be able to reference those. I remind you again on the equations. This is nothing more than your normal y equals mx plus b, but they reverse. So mx plus b, and then they switch the variables on you, okay? Where you used to b standing for the y-intercept, well, now b is the slope, and a is the y-intercept. And then over here, you have an additional formula then for your slope. Your slope is the correlation coefficient multiplied by the quotient of the 2 standard deviations. All right, so if you are asked to interpret slope of a regression line, this is some wording that you can memorize. I won't read that to you right now. We'll actually do it in the context of this problem. All right, so this was the regression equation. And I said here, write the equation using statistic notation for predicted wins. I'm not going to rewrite that whole thing. I'm just going to do it right here. When you want to talk about something being predicted, you use the little caret, the little hat. Well, I told you on the other page, it's called y hat. So since we're going to be using this regression line to predict the number of wins, you literally can just put a little caret over top of that. And this is now read as the predicted number of wins is equal to, okay, then you have your y-intercept, you have your slope, and then it's being multiplied by the rushing yards per game. That's the easiest way to do it. Now, some people are like, no, I like to see my x's and my y's. Well, you can do that. You could write this as y hat equals negative 2.980 plus 0.05994 times x. You can do that. But now what you're required to do is off to the side, say that x stands for the rushing yards per game, and y hat stands for predicted wins. And I'm like, why would you want to take the time to write all that extra stuff when if you just put the symbol up here, that's acceptable. Then the variables are defined within the equation itself, okay? Enter the data from page 1, use your calculator to find these values. Okay, so would you know how to do that? Would you know how to put this data in your calculator and get all of these things out of here? Okay, I'm going to just save some time and I'll tell you what the values are, okay? Just if you had to, you could put this in the first column. You could put this in the second column. And Michaela, I'm going to go back to what you pointed out the one day. If this is your L1, or you call that your column X, and this is your L2, or you call it your column Y, on the 84, you could do 2 variable statistics, and you can get your X bar and your SX, and you can get your Y bar and your S sub Y in the same step. Okay, on the On the Inspire, you can always do multiple columns anyways, okay? If you need some help with that, we can talk about that another time, but to save ourselves some time, I can tell you that X bar, the mean number of rushing yards for the Big Ten that year was 162.9. The standard deviation was about 38.5. Remember, those are in the same units, actually. Y bar, the mean number of wins, was 6.8. And the standard deviation for Y was about 2.9. Okay, remember, those are in the same units. And your correlation between the two, your R value, was 0.784. So a fairly strong linear relationship. And we can say that because we've seen it. We can see that there is somewhat of a linear trend there. Remember, R has no units. All right, use the formula to confirm the slope. Okay, I said see page 1 or the formula page. So I just want to make sure we practice using this formula. So on the formula page, it will tell you that the slope is equal to the R value times the quotient of the two standard deviations. And I always remember that it's S sub Y over S sub X. Remember when you were in algebra and do you remember doing like slope, and sometimes teachers called it like change in Y over change in X? Do you remember that? All right, it's the same thing. The Y's always go on the top. All right, so if you didn't already have this equation and someone just gave you these 5 values, you could calculate the slope. You could say that the slope would be equal to 0.784 multiplied by 2.9 divided by 38.5. And I'm doing this because this does happen sometimes on the AP exam. You don't have the data set. You don't have the regression line. They will give you these 5 numbers and say, what's the slope? It's not hard. You just have to know where to look. You have to know what the formula is. So I'm going to take 2.9 and divide by 38.5. And then I'm going to multiply that by 0.784. And this says 0.059. And that sure pretty much matches. It's pretty close to my slope. Now, it's not exact because all of these values that I told you to write down were already rounded. But you could confirm that 0.059 is approximately the slope. And by the way, you can do this all in one step. I did it in 2 steps. You should be able to always just take the R value, multiply by the numerator, and divide by the denominator. And you should be able to always do that just in 1 step. Your order of operations will be fine on that, okay? Now it says interpret the slope in context of the situation. So I do tell people to go back and think about when you were in algebra and we talked about change in Y over change in X. And I tell people to start at the bottom. For every increase in, and now you talk about what are we going to do to the X? Okay, for every increase of 1, and X is measuring for every increase in 1 rushing yard per game, the number of wins is expected to, and I said go up or down or increase or decrease, is expected to go up or increase by about, okay, and now it's to state the value of the slope with units, by about 0.059 wins. You literally are just describing what the slope is, okay? So if your slope was 0.059, you could say 0.059 over 1. Okay, you always start by saying for every increase in 1 unit of your X variable. So for every increase by 1 rushing yard per game, the number of wins for the teams in the Big Ten in 2017 is expected to go up by about 0.059 wins. And I'm going to underline a couple of these things. You want to, again, leave it a little bit vague. You can't just say for every increase in 1 rushing yard per game, wins will go up by 0.059. Okay, no. This is all estimated, and this is all approximate. Okay, these are predictions. So we're expecting it to happen by about this much. At no time do you want to make it sound like this is the answer. Okay, this is just approximately what we think we're expecting to happen. Okay. Now it says interpret the y-intercept in context of the situation, if possible. You have to know that the y-intercept will not always have meaning in a problem. And for most of you who had me in Algebra 2, I made a big deal. I didn't give you credit for writing an intercept if you didn't put the 0 in and call it an ordered pair. So the y-intercept would actually be 0, negative 2.980. I write that down because that helps me remember what the y-intercept represents. Because I know that X is measuring rushing yards. Okay, so this is rushing yards per game, and the Y value is measuring the number of wins. Now, the interpretation of this is simply, if a team has 0 rushing yards per game, they will win negative 2.980 games. How's that sounding to you? Pretty stupid, right? Okay, so you know what? No context meaning. Okay, in this situation, it doesn't have any meaning. Now, you think of something else. You could be like the number of cars. If X is measuring the number of cars in the parking lot and Y is measuring the number of people at a tailgate. Okay, would it make sense that you could say that there are no cars and therefore how many people would be at the tailgate? You could do that. Okay, the y-intercept might have meaning, but not necessarily. So literally just think about the ordered pair and say, does it make sense if X is 0? Does that value make sense for a Y value? And you're like, no, that doesn't make sense. So it doesn't have meaning here. Confirm that the point X bar, Y bar is on the line visually. And this goes back to the little interesting visual I showed you in 3.1. All right, I just got through telling you that X bar was 162.9. So if I went to the graph and found approximately 162, okay, maybe like right about here. If I kind of drew in, okay, in fact, is this 161.7, 4? Okay, that's probably about 162 then, right about in here. Okay, so 162 is about in here. And Y bar, I just said, was 6.8. So somewhere like right about in here. Where those two horizontal and vertical lines intersect, okay, this was my X bar, this was my Y bar. That point of intersection should always be on the trend line, always, okay? Your X bar, Y bar should always be on the trend line. So I said confirm it visually, and then I said let's confirm it algebraically. So if you have this equation right here, and this goes back to the formula page again, this is what they're showing you right here. Is that you should be able to plug in X bar and Y bar, and it should work. So instead of Y hat, I'm going to call that Y bar, which was 6.8. And then the y-intercept, negative 2.980, plus my slope, times, now instead of X, I'm going to put X bar in, which is 162.9. And I'm just going to confirm that. Just going to confirm. And this is nothing more than to prove a point. It should work. Negative 2.98 plus 0.05994 times 162.9. I hope that comes out to be 68 or 6.8. Pretty darn close. 6.78, round off here, okay? Again, all of that is just to really cement for you. X bar comma Y bar is on the trend line. It fits the equation. You can see it on the picture. Now it says use the best fit line to predict the number of wins if average rushing yards would be 400. Okay, not 400. Do we ever get average rushing yards of 400? Did that ever even happen? Okay, that sounds kind of big. All right, but if we did put that in, average rushing yards, okay, that's going to be an X coordinate. So I would say the number of wins would be predicted to be, and I'm going to put this into the equation, and I'm going to put the 400 in for the rushing yards per game. So I'll pull up my calculator again, negative 2.98 plus 0.05994 times 400, and I get an answer of 20.996. So I predict about 21 wins. And of course, for anyone who knows anything about college football, do they play 21 games in a season? No, they don't. Okay. Juniors, you just talked about this in physics, I think, didn't you? This thing called extrapolation. Okay, that's what this is. This whole model is only an appropriate model based on this data. Okay, it goes back to algebra. I used to talk to you guys about domain and range all the time. Okay, the domain on this graph went from 100 up to about 250 because that's what my data did. Okay, this trend is only appropriate for this domain. Once you get out of that domain, you are now guilty of what we call extrapolation. You are trying to apply a trend into a situation that's no longer applicable. And again, this, you might not remember this, but there was a problem we did in Algebra 2 last year for most of you and 2 years ago for some of you. We were doing exponential growth. And we were trying to, we were predicting the world population. And our book had been written in 2007. So when we used the model to predict the current population, it was not accurate because we were so far beyond. I mean, that book was written in 2007, which means the data was based on before that. Okay. So we were trying to use an exponential model to predict well beyond when that trend was even appropriate anymore. It's called extrapolation, okay? Whether you're doing linear regression, exponential regression, or whatever. All right. Residual plots. So I talked about residuals on the first page. And you guys can flip to that page. I'm going to go back to the first page of the notes and remind you what a residual is. A residual is the vertical distance between a point and where you would have expected that point to be based on the trend line. Now I say vertical distance, but where distance doesn't necessarily show direction, call it a vector because we need to also, a residual also tell you whether you're above or below the trend line, okay? So if you do y minus y hat, so in other words, the actual y value minus the point on the line, that's your residual. So the actual y value minus the point on the line, that's going to give me a negative residual right there. Because when I do y minus y hat, I'm going to be doing a smaller number minus a bigger number. If I do this y minus y hat, that'll give me a positive residual, okay? All right, so what do? We have to learn how to make a residual plot. All right, so we do need our data in the calculator anyways. Let's put our data in because we need it to make a residual plot. All right, so back to this page, pull out your calculators. All right. 84s, remember the trick I taught you with the decimals? Okay, I wouldn't put any decimals in there. I'm just going to put them all in without a decimal, and I'm going to divide by 10 at the very end. I probably even have this in my computer somewhere. I just was working on something else and forgot to download it. All right, so I think. All right, so I think I have my 84 in. New document, listen spreadsheet. RY for Russian yards. And I'm recording this. This is a great video right now, isn't it? Can you imagine watching this from home? You're like, wow. I know, I'm winning awards. I miss my calling. All right, I got to get my Y column in for my inspire, and then I'm done. Call that W for wins. All right, I think I got mine in. Got yours in? I hope so. I did two. I did two different calculators. You should have one done. Okay, so let's see. So a residual plot is a standard plot of the residuals against the explanatory variable. So what I have in my calculator right now is I have it like this. I have L1 and I have L2. We're going to need a new column, L3. And what I'm going to call this one, I'm going to call it, I called my X column, I actually called it RY for rushing yards. I called this column W for wins. And what I'm going to do on this one, okay, obviously 84 is you just call yours L3. But what I'm going to do for the inspires, I'm going to call it PW for predicted wins. Okay. And what you're going to do on this column is you are going to write a formula, and your formula is going to be your trend line. Okay. Your formula is going to be your trend line. So you're going to take, let's get that in first, and I'll tell you what we're going to do with that. All right, so I'm on my 84, so I go up to my formula bar, and it already has the equals on the 84, so I'm going to type that. So what I'm going to do is I'm going to start typing my trend line, which was my y-intercept was negative 2.980, plus the slope was 0.05994 times, and what you're going to do is you are going to use your X values. Okay. So for my inspires, I'm going to go up to the tippy top, and I'm going to call this PW for predicted wins. PW. Hit the equal sign to tell it you want to do a formula. Negative 2.980 plus 0.05994 times, and I want to use my X column, which I had called RY for rushing yards. So I hit variable, rushing yards, and then enter. So assuming the trend line is supposed to represent my predicted values based on these X's, okay, these are now my predicted values. So these were the actual number of wins. So this is what we would call Y in the residual formula. And this is now the predicted number of wins based on the trend line. So this is like y hat. So the next column you're going to make is going to be your residual column. This is the part that I said you need to memorize this. You need to know the residual is always the actual y value minus the predicted. So I'm going to call this column RES for residual. And my formula is going to be, I needed to take what was in my original Y column, which I had called W for wins. So variable W minus the predicted wins, what would have been called W hat using notation. Those are your residuals. Every time you have a negative residual, it means the point was under the line, okay? So that first one is a negative residual. If I go back and look at the graph, okay, yeah, the first point was under the line. See how the next point is above the line? Yeah, my next residual is positive, okay? A negative residual means the dot, the point is below your trend line. A positive residual means that your point is above the trend line. So 84s. What we really want is here's y hat, we'll call it wins and predicted wins. So I'm going to go up to the top of L4 and I'm just going to do L2 minus L3. And there they are. Those are your residuals. A residual plot now. A residual plot does residuals against the explanatory variable. I think I mentioned one day, and here I use the word against, but Minitab will use versus. And when you see that phrasing, they're telling you that this goes along the vertical axis, and of course the explanatory variable is on your x-axis. So we're going to be making a graph that is still going to put rushing yards along the x-axis, because that's my explanatory variable. But instead of putting wins on the y-axis, I'm now going to put those residuals. So I'm going to go back to my calculator. I'm going to go to my stat plot. I'm on my 84, obviously. And I'm going to make a scatter plot again. But my X list, I still want rushing yards, so L1. But I don't want L2 now. My residuals were in L4. And then on the 84, I always like to do zoom, option 9 for zoom stat. That's a residual plot. If you're on an Inspire, okay, we're gonna add a page on this. Option 5. Along the x-axis, I want to leave my rushing yards, but along the y-axis, I want my residuals. And that is a residual plot right there. Now, what exactly is a residual plot? It honestly, if you could picture this, if it wasn't all written all over, and if you could picture that it almost just got, I'm just going to say almost rotated, so that the trend line is now horizontal. That's what you're looking at on a residual plot, essentially. Okay, so when I'm talking about how this point was above, so we have this one's below, then above, barely above, and above. If you look at your residual plot, can you see the below, barely above, barely above? You literally are seeing the exact same thing, but it takes the trend line and makes it a flat line, so you can very quickly see above versus below. Okay, it just allows you to very quickly see above versus below. So if you looked at this trend line, you said there were 1, 2, 3, 4, 5, 6, 7, 8 that were clearly above. 1, 2, 3, 4, 5, 6, 7, 8 that were clearly above. All it does is take the trend line and put it horizontal so you can really see the above versus below. Okay. But residual plots are used in statistics, so you need to be familiar with these. So I think we've done this now. We created the new column, and then we did residuals, then we made the scatter plot. The horizontal axis now represents the regression line. So we did that example. So how do you interpret a residual plot? Because what's going to happen on the AP exam sometimes, you're not going to see the data. You're not going to see the original graph. They're going to show you a residual plot and say, hey, what does this tell you? What you want to look for on a residual plot, okay? There should be no pattern in the residuals. It should literally just be a scatter of equal above, equal below, but all over the place. No pattern. Now, this is not a great scale for a residual plot. I think I would have done a scale that stopped here and here so I could see it better. But this, in general, a linear model is a good choice here, because if you looked at this residual plot, you're like, okay, some are above, some are below, it's just random, some are on the line. This is bad. Do you see how there's some above and some below, but they're starting to get wider and wider? That's a pattern, okay? It means that there is probably some pattern in the original data that wasn't aligned, okay? This one, okay, clearly curved, right? Yeah. Well, it also means that the data was probably curved like that. That was probably a better quadratic model, okay? So bottom line is, when you look at a residual plot, you are looking for no pattern. You just want above, below, and not even up, down, up, down, up, down. Okay, even that's too much pattern. You just want half above, half below, approximately, okay? And I also added this note a couple years ago. We did, in the last unit, we did a normal probability plot. And I started having people confuse the two. On a normal probability plot, if you remember, you were looking for those dots to be about in a line. That meant we had a normal distribution. For a residual plot, you're looking for randomness, and that means you have a linear trend. Okay, just be careful. I have people confuse those two and they start looking for the wrong thing. Okay. All right. I think the homework probably goes up to there, pages 1, 2, and 3 of the notes. Yes. So the homework that I'm assigning will go up to there, but I'm gonna start the next portion. Okay, but what we do here, this will not be part of the homework. What we're going to start talking about in this thing is the difference of R versus R squared. Okay, because I know you guys have seen both, and people are always like, "What's the difference? Why can't you? Why does it matter?" There is a difference. Okay, so R is a way to quantify the strength of a linear relationship. Okay, R squared is how we quantify how well, once you determine that there is a linear relationship, how well does your model actually fit your data? Okay, so R is measuring the strength of how good is our linear pattern, but then R squared is going to say, okay, now that we have our trend line, how well does it fit the data? Okay, so R and R squared are very much connected, but they're a little bit different, okay? So we're going to be looking at these things. One of them is called SSE. The next page, we're going to do something that's called SST. And then on the next page, we do something called SSR, okay? And those three things are going to be how we calculate R squared. Now, I'm not actually going to do this today. I'm just going to kind of walk you through the titles on these charts. You will notice that this chart, and if you look at the chart, it looks an awful lot like what we were doing when we did standard deviation, okay? We're going to subtract, but then we're going to square to get rid of the negatives. But you'll notice what we're doing here is we do y minus y hat. We're going to be doing the actual y value minus our predicted y value. So basically, this is your residual, and this is going to be your residual squared. So we're going to look at that tomorrow. And then we're going to do SST. You'll notice it looks awfully similar, But instead of doing y minus y hat, now we're going to do y minus y bar. And this one really will look kind of like standard deviation. And then we're going to square things to keep it positive. And that's where we're going to calculate SST. And then we're going to put the SST together with the SSE to talk about SSR. Okay, and I said I won't totally get into that right now because we're so close to the end of the hour. So your homework then is, it says pages 1 to 3 of the notes. Okay, keep in mind that's when this is not copied as a packet. So in other words, the first 3 pages of the 3-2 notes, you should be able to do any of this homework. Okay, and then it says on 47B, when you get to 47B, I think they actually ask you to do 2 things on part B. And I'm telling you, you only have to do the first part. Okay, they're going to ask you another question after that. Don't worry about it. Okay, you're just going to use the regression line to predict. And then we'll finish the notes tomorrow. And we'll be done with chapter 3 and be getting ready for another test already. Yeah, you just use one of those passes. So, Mr. Costello, I needed to look up something on Google. I needed a paint cow logo. Okay, so I do a search, paint cow logo. But because of the keywords on a search, you get all sorts of things. And so anything I had paint cow in it came up on my image search. And I find this picture from Career Night. Your brother Aiden looks like he's about 12 years old. I literally took a picture of it instead of Snapchat because he was in it, Brendan Goff, Sheldon Graham was in it, Boyle. And I sent it to them and I was like, oh my God, are you guys 12 or what? He looked, and your brother could do it, look at this collie. It was so funny. I was cracking up. Yeah, Aiden is not very tall. I gotta do that part. Oh, there it is. My sister's like 5'8". Look at him in the middle.
I know it's on my computer.
Look at him, there he is.
I just want to make sure I had it up.
Oh my God.
Seriously, isn't it hysterical? Oh my God, they all look so young. I was cracking up.
I don't want to say how you literally have even want to do Oh yeah, the red one? Yeah. Why they had to do that? Oh, I didn't.
That was pretty nice. That was just one of the Discord night show, yeah.
too bad. Under my table, trying to drag me to bed.
This will not go.
Yeah, but yeah, it's one at a time, counting. No, I was too select. Yeah, she was.
Yeah.
We need 10 more to make them 200.
Times 0.0599.
I think, I hope you had. I run down the story. Yeah, I was 3 months, gonna have no. I don't have any already. Yeah, but I hope you had my story too. If only would have. You guys all have, you guys have the same face, all like different hairs, it's so weird. I forgot my exact.
I literally, I can only.
That's so bad.
People get things. Actually, not that different.
All right, I think I'll just record my.